Hello, and welcome to the introduction of Chapter 9, where we will talk about blood pressure and the physiology behind it, and how we use our understanding of that physiology to measure blood pressure in arteries. So we can define blood pressure as a measure of the average pressure in the blood in arteries. And the reason that we take an average is because you remember the pressure can change, or the activity of the heart is changing. And so there are two phases. Remember, there is systole and diastole. And remember, during systole, the ventricles are contracting, so it's during this time that the pressure in the arteries is higher. And then during diastole, the pressure is lower. And so we define those two times as systolic pressure and diastolic pressure. Typically, those values for men are around 120/80. We list this as systolic pressure first, and then diastolic pressure second. An average for women is around 110/70. We can also determine something called pulse pressure, abbreviated as PP. This is the systolic pressure minus the diastolic pressure, and so what this does is it essentially allows us to isolate the amount of pressure exerted during systole. And we also measure something called mean arterial pressure, or MAP. Mean arterial pressure is the average arterial pressure over time. So we determine that by taking 1/3 of the pulse pressure and adding that to the diastolic pressure. So you're probably thinking, why 1/3? Well, if you recall, systole and diastole are the two phases of the cardiac cycle for the ventricles, and they don't spend equal amounts of time. So about 1/3 of the time is spent in systole and about 2/3 in diastole. And so to compensate for that difference, we use this formula to get an overall average pressure. So we know a little bit about the numbers. Let's take a look at how we can measure blood pressure and what's actually going on in the arteries when we do that. So the first thing that we want to do is we take our blood pressure cup and our stethoscope. And the blood pressure cup is equipped with a sphygmomanometer. And what it can show us is the amount of pressure that we're exerting with the blood pressure cuff. So the first thing we want to do, if we're following along over here, is we want to increase the pressure in the cuff so that it's higher than the amount of pressure exerted by the arteries during systole. So without a blood pressure cuff, the blood flows through veins in a laminar way, and laminar flow doesn't make any sound. So without the blood pressure cuff, if we take the stethoscope and put it on one of our arteries, we should hear nothing. So then we take the blood pressure cuff and we increase its pressure so that it's above the systolic pressure. And because it's higher, it limits, or it actually prevents, any blood from getting through the arteries. And so we should hear nothing during this time as well. So then we start to reduce the pressure on the blood pressure cuff until we get to what are called the sounds of Korotkov. So here's our first sound right here. And what happens during the first sound is the pressure that's exerted by the cuff is equal to the pressure achieved during systole. And so that's represented here in the graph. And so what happens is we get a small amount of turbulent flow moving through the artery during systole, but during diastole, the pressure is still too low to overcome the pressure on the blood pressure cuff. So we get our first sound, and it should sound like a little thumping noise. And that's because turbulent flow has been caused by that blood only getting through when the pressure exceeds the pressure exerted by the cuff. We can also, in addition to hearing that sound in the stethoscope, we should be able to see the needle on the sphygmomanometer jump. every time a little bit of blood gets through the arteries. So then we continue to decrease the pressure exerted by the cuff until we get to the point where the amount of pressure exerted by the cuff equals diastolic pressure. And that's when we get to the second sound of Korotkoff, and you might be thinking this shouldn't be very noisy, and you're right. So the second sound is essentially the sound of silence, because laminar flow should be achieved then, and we will stop seeing that needle jump and we will stop hearing sounds. So when you guys are completing the lab for exercise 9, you'll notice there are 3 videos that you'll watch. These are YouTube videos. There are links embedded on D2L. And make sure your volume is up on your device, because it's important that you listen carefully and watch the needle carefully when you determine what the systolic and diastolic pressure are in the arteries. I hope this has been helpful. Please tune in for the next video, and we'll talk about exercise 10 and things that affect mean arterial pressure.